Today we're going to work on factoring again. If I had x squared minus 7x plus 12, I put that in the box. I stick the x squared in, I put the 12 in, multiply those together, 12x squared. Now that number is positive. What does that tell me about the factors? They have the same sign, and then I look here to see that they're both negative. Are you getting, you understand that? I know you had some trouble with that yesterday. Okay, so minus, minus. Now I go through the factors of 12 and try to get a 7. So negative 1 and negative 12, that doesn't work. Negative 2 and negative 6, that doesn't work. Negative 3 and negative 4, that's the one I want. I put in a negative 3x and a negative 4x, and then I look at the top row. What does the top row share? An x. And if I take an x out, I'm left with x minus 3. Then if I take an x out of the bottom left box, I get a negative 4. So my factors are x minus 3 and x minus 4. And if the problem just wants you to factor, then you're done. What are the roots? X equals 3 and 4. Okay, let's do another one. Draw the box. Put in x squared and negative 16. Multiply those and I get negative 16x squared. That number is negative. What does it tell me about the factors? One is positive and one is negative, and this number tells me that the bigger one is negative. I write down the factors of 16, 1 and 16, and we know that the big one is negative. Is that what I want? Does that work? Yeah, it does. 1 minus 16 is negative 15. So plus 1x and minus 16x. Pull out an x, and I'm left with x plus 1. And then pull out an x from this one, and I get negative 16. So my factors are x minus 16 and x plus 1. What are the roots? 16 and negative 1. You getting the hang of this? Okay, let's do 3x squared minus 9x. Hang on, I gotta do this in my head. Plus 6. What can you tell me about this one? I need to pull a 3 out. Is that 3 important? It depends. The 3 is a factor, but the 3 will not affect the roots. So if you're factoring the quadratic, then the 3 needs to stay. If you're finding the roots of the quadratic, then the 3 is not important. I'll pull out a 3, and I get x squared minus 3x plus 2. And I want to put this stuff in the box. X squared plus 2. Multiply those together, and I get 2x squared. That number is positive, which tells me they're the same sign, and the middle sign is negative, which tells me they're both negative. So negative, and I factor, and I get 1 and 2. Do those work? Yes. What if they don't work? What if none of the factors work? Then it's a prime quadratic. Does that mean it doesn't have any answers? No. So if a quadratic does not factor, that does not mean that it doesn't have roots. It means either that the graph misses the x-axis, which you might think doesn't have any answers, but it turns out that it does, or it does hit the x-axis, but it just hits them at really nasty numbers. You know, some decimal that goes on forever. Okay. These do work. negative 1x and negative 2x. So I pull out an x, and I'm left with x minus 1. And I pull out an x, and I get x minus 2. The factors are 3 times x minus 2 times x minus 1. Does this have a root? No. Why not? There's no x there. But these two both have roots. When I set them equal to 0, I get x equals 2 and x equals 1. What if my original problem looked like this? 3x to the third, 9x squared, and 6x. How would that change things? I would pull out a 3x, and then over here I would have 3x, and that adds a root. What is the third root? 0. Okay. I need to do one more, but I don't want to do it in my head. Okay, let's say, no, 3x squared plus 11x plus 6. Can I pull out a 3? No. Which tells me what about the roots? If that leading coefficient does not factor out, what do you know about the roots? At least one of them will be a fraction. One or both roots will be a fraction. The process is the same. 3x squared and 6, multiply those together, and I get 18x squared. That number is positive, which tells me the signs are the same. And the middle term is positive, which tells me they're both plus. So plus and plus. Now I want to create an 11 using the factors of 18. Do 1 and 18 work? No. Do 2 and 9 work? Yes. I put a 9x and a 2x. What does the top row share? 3x. If I pull a 3x out, I'm left with x plus 3. And then if I pull an x out of the left column, I get a plus 2. How do I check to see if I did things correctly? When I get to this stage, there's a really easy way to check. Is this times this equal to that? Yes. If the remaining two constants multiply to be that bottom right box, then you probably did things correctly. Either that or you made two mistakes that kind of canceled each other out. But that's a good way to check. So I now have x plus 3 equals 0 and 3x plus 2 equals 0. What is the root here? Negative 3. And this one's a little bit harder. What do I do? Subtract the 2, divide the 3, and I get negative 2/3. And just like we said, one of them is a fraction. Okay. There was one on your assignment from yesterday that I want to do, that one that you asked about. What is it? 4a squared ab b squared, 4b squared. Okay. Can I pull anything out? A 4. So 4 times what's left? A squared plus 2ab plus b squared. I took a 4 out of each of those. Now, this looks really tricky, but the rules are exactly the same. Draw a box. A squared and b squared. What happens when I multiply those together? I get, and I'm going to write 1 a squared b squared. Are there factors of a squared b squared that add to be 2ab? This one's a little tricky. Let me do a different one. In this one, I would have x squared and 1x squared. Are there factors of 1 that add to be 2? 1 and 1. 1 and 1, and I write 1x and 1x, and I get x plus 1, and x plus 1. So, are there factors of 1 that add to be 2? Yeah, 1 and 1. So this is plus 1 and plus 1. Now for the tricky part, what do I do with the a's and the b's? Well, they need to add to be 2ab. So what would the factors be? 1ab and 1ab. So 1ab and 1ab. Now let's check. Is 1ab times 1ab equal to a squared b squared? Yes. Is 1ab plus 1ab equal to 2ab? Yep. What does the top row share? A. If I take out an A, what's left? A plus B. If I take out an A over here, I get A plus B. So my factors are 4, A plus B, and A plus B. That one was kind of tricky. Okay. Exercises 2.6. I want you to do um 31. Let's just do 3 through 31 odd. Okay. Good luck.